Design the Amazon Kindle payment system. Hey everyone, welcome back to another Exponent system design mock interview. My name is Kevin Wei and I am super excited today to be doing a video with Curran. We're going to be doing a technical system design mock interview. And before we get started, Curran, do you want to introduce yourself or say a few words first before we jump right into the question?
Yeah, sure. Hi, I'm Karan. I'm a senior software engineer at Curebase, and previously I worked for Smithsonian Institution.
Cool. Thanks for coming on today's show. And Curran, I know that you also have a really in-depth, very amazing open source system design course on GitHub also. So be sure to check that out after the video if you guys are curious. So here's a question that I'd like to ask you today. Design the Amazon Kindle payment system.
Okay. Interesting. So Amazon Kindle. So I'm going to be honest, I haven't used Kindle before, but from what I understand, it's basically a device that lets you, purchase book and then kind of like read it. So I want to start with the requirements and see where we are at and what features would we like for this like MVP.
Sure. Yeah, that sounds
That sound good?
Yeah.
Perfect. I want to start with functional requirements first. And for functional, the first thing that comes to my mind is with transactions and payments is the consistency. We need some sort of consistency. So I will write consistency. Again, this is like the acid stuff. The second thing that comes to my mind is what's kind of the typical user flow. So in my mind, just like user, they have like books will be like a digital goods. So there's no restriction about quantity. So it's going to be one. And then we have digital goods, and we also need to have like archive payments.
Sounds good.
Okay, let me split this into two parts. I guess digital goods is fine here. So another requirement is again archiving payments. Because with these types of system like payment and there comes like a compliance. So this will probably fall under GDPR, and with this we can also discuss PCI compliance, which is like big for payment systems. And my last functional requirement would be would be notifications. So this is very essential. So once the user purchase something, or we need to be able to send them notifications and invoices that hey, your payment has been done. You can start reading a book or whatever thing you purchased. So
Got it.
this will be invoices.
What it sounds like is that the primary use case that we're going to be designing for here will be a user purchasing a book within Kindle. Is that right?
Yes.
Okay, sounds good.
Perfect. So I also want to discuss some non-functional requirements. And for non-functional, again, we have, the classic consistency is important. And then we have minimal latency, high scalability, the usual scalability and availability. But the thing is, I will get back to this later, because if we have a consistent system, we have to make a trade-off with availability. And I think get back to that later when we get into the actual design. So this is kind of the requirements I'm thinking about. What do you think?
Yeah, this sounds good. And yeah, let's definitely circle back and talk about like the cap theorem and how you'd weigh those trade-offs here around consistency and availability later. But feel free to continue.
Yeah, absolutely. Okay. So my next step would be having some sort of like basic estimations, what about the storage, request per second, ingress, and whatnot about our system. So that should give us like some estimate. So I'm just going to create this here again. Okay, so estimates. Okay, so I'm gonna start with, let's say, how many daily active users do you think our system will have? 10 million, 50 million?
Sure, let's say tens of millions.
Okay, we have 10 million daily active users, and maybe they buy on average 2 books a day, maybe, like an average, so this will give us like 10 requests per second would be like, we have 2 books a day, so at least they are transacting 20 million requests, and it would be 600. Yep. Okay, so this should be, I think, around, let me think. 86, 400. I think this should be around, let's say 500 by 1200. I think, yeah, it should be around 600 requests per second. Next, I want to look into storage. Like, let's say if we have, 20 million requests a day, what would be our storage for a day? So
And
20
what do
million
you think?
requests.
And what would the main files that we would be storing here?
Okay, so main files, unlike other systems where we store like static images, videos, here we will just have like a database record, like nothing big. So I'm envisioning like, if we have like 500 bytes of storage per record, I think that should be enough. What do you think?
Yeah, that's fair. Let's go with that.
Okay, because we'll just be storing like, transaction IDs, and we'll look into that in detail when we kind of get back to the data model. But let's assume 500 bytes for just, back of the envelope estimation. So 500 bytes, and this would be our storage for a day. I don't know. Let's do some math. It should be, I think, around something around 200 gigabytes per day, in my opinion. And for 10 years, this would be, 12 into 365. This should be around it should be around 750 terabyte, I think. Okay. And lastly, just to ingress, how much traffic, how much megabytes or gigabytes per second of traffic we are serving, our servers will be serving. So for that, I'm gonna use our storage for a day, or RPS, and then kind of calculate per second how much we serve
Sure.
that traffic. So let's do 200 gigabytes, and we can divide by 3600, 24, the standard, 1 day into seconds thing. And this should be about 4 MB per second. So how does this sound to you?
Yeah, this sounds good. Let's dive into the design here, and I'd love to see like where you'd go given this information.
Absolutely. Let's start with the design. Okay. Again, this is not a very, read heavy system. I think it would be mostly like write heavy. So for design, I would start with, let's start with the basic. And I'm gonna take a like sort of like a microservice approach here. Let's say payment service. And we have this thing, and we need some sort of like database. Okay, so payments DB. Okay, and let's also create a user. So I'm just trying to map out the request flow, how user journey will go through our system. So this will be user, and they will have like a, let's say, do they have? Oh, of course, like a Kindle logo, and Kindle will essentially serve as a front end, just like mobile devices. So they will be just sending requests to the backend. So let's do the purchase, and let's do Kindle. Okay, I'll get back to this step and go to the payments DB. But then again, we will, so our first requirement is consistency. Let me kind of pause here for a second and talk a little bit about the database we will be, using. So I think relational database like Postgres or, Amazon RDS with Postgres will be a great choice here because we need that asset consistency. This is getting back to the the availability and consistency trade-off. So my first goal here would be to just use a simple SQL relational database and just call it a day. But world is not that simple. Unfortunately, we need that availability. So we can look into distributed database such as like Cassandra, Apache Cassandra, and things like that. But then how do we guarantee that asset? So we can shift our focus toward more like base and eventual consistency and implement something like distributed transaction, two-phase commits, sagas that can get us around the, the consistency bottleneck. But
Yeah.
I think both points are fair. If you want to take relational database, it will simply, it's a trade-off, I guess. We can either use like a relational database or we can go with like a distributed database. And if we go with a distributed database, we'll have to embrace, the eventual consistency model, the base model. And then we will have to look into things like distributed transaction, distributed consensus, and implement protocols such as two-phase commits, sagas to get this use case. So that's where what I was referring to at when we were discussing the requirements.
Got it.
How does this sound?
Yeah, I think that sounds good. Would your choice here be different if we were designing for more users, like maybe billions of users?
Yes, for billions of users, the relational database can be a bit of bottleneck, and it's not that it doesn't scale. It's more like it's little challenging to scale. So if we were designing for billions of users and we want to stick with relational database, then we'll have to look into things like sharding and consistent hashing, get those like clusters up. And I will get back to sharding when we discuss how we will route requests based on maybe user region where like laws are different about payments and things like that. But
Got
yeah,
it.
sharding would be my first step to get to what, like scale the system, start scaling the system.
Yeah, some kind of partitioning or sharding makes sense. Feel free to continue. Everything up until DB here sounds great.
Perfect. Okay. With every DB comes a cache. So let's try to add some caching. And I'll just do here and kind of like briefly talk about caching. So in this particular system, Kevin, I don't think we need too much caching. We just want to cache, let's say, so this is more related to the requirement number 3. When we request like old payments, historical payments, we can cache the 20% of the request, like, 2080 principal, and with like, let's say, least recently used policy. And I think this should serve us fairly well for caching.
Yep, makes sense.
Perfect. Okay. And status is perfect. Okay. Payment service. We have our consistency now, and we have our archiving method. And okay, this also ties into notification. So, okay, before notification, let's complete the payment flow. Okay, so as you know, we cannot just, transact users without getting into compliance and stuff. So for payment, how it works is that we need some sort of like payment service provider that kind of integrates with us. This can be like Visa, MasterCard, commonly nowadays it's like Stripe and things like that. We need like a payment service provider that can go to a issuer bank and transact and forward the payment to Amazon accounts and merchant accounts, as you will. Does that sound reasonable?
Yeah, that sounds reasonable. Feel free to abstract away like the issuing bank and the acquiring bank sort of logic, if it makes it easier here. But I'd love to see just sort of like what happens when a user tries to purchase a book on Kindle, and maybe you can kind of walk me through how that interfaces with like the payments and notifications.
Okay, sure. So I'll just quickly abstract the logic for the payment service providers. Okay, let's do. Uh, okay. Mm, okay, cool. So this is like a very brief abstraction. So let's look at the interface we will have for conducting payments and retrieving payments. Let's do some like API, very basic API design. Okay, so I'll just copy this. Let's do API. So for API, I would stick with like REST API. So it would be, okay. The first API I would like to visit is the, the a core API, which would be payment. So this would be like a post API v1 payments. And here we will just have, a pay method, which will take in a user ID. I'm assuming here that the user will be already authenticated with some sort of like Amazon account and things like that. Okay, so we have user ID, UID, some sort of like we need a payment method. I'll just do method, which would be like an enum of like a string, like what do you want to transact with, a credit card, debit card, or net banking, and we will have the amount, and finally we will also have currency. So currency will also be an enum of string. If I'm remembering, it would be like an ISO 4217 string, which is like the standard currency notation. And yeah, So this is kind of the thing about like the method that will be used for payment, and we can return like a async thing like boolean if the payment was complete or not, maybe an error. Okay, so does this how does this look to you?
Yeah, this sounds good. Feel free to continue.
Perfect. Okay, I'm just trying to make sure like we are on the same page. Mm,
Totally.
okay. So as this system is simple, we'll need another API, let's say get all payments. So I'll just quickly mock it out again, get API v1, payments. We can get into more into like, REST API, GraphQL, and gRPC, but for now, let's stick with REST unless we have some concerns, specific
Uh,
concerns we need to address.
yeah, no immediate concerns here with using the REST API.
Perfect. So this is kind of our API I'm envisioning. Um, so it's fairly simple and it should fill the use cases of the user. So let's talk about the user journey that you mentioned. Okay, user purchases a book from Kindle and it is redirected to the payment service. They are redirected to the payment service and they will, of course, see us the classic screen, wait while we process your transaction. Or like that's the kind of like a standard. As we reach out to the payment service provider and they do their thing, they will issue a callback to our payment service, and then we can update the state of the user and say, hey, your payment has been successful, payment has failed, and so on. Um, for a better experience, we will use WebSockets so we can push the updates to the user in real time, near real time. We can also use server sent events, but I think WebSocket would be great. Okay, and okay, next I would like to talk about the notification service. So to issue notification, I'm going to keep things decoupled here and issue a message broker like a Kafka, and we can publish events or topics. Based on the status of the payment, we can issue events like payment success, payment failed, and Kafka can forward that to the consumer. So here payment service is the producer and notification service would be, let's say, a consumer.
Mm-hmm.
Okay, so let me quickly mock it out. And again, we can reach out to, let's say, SES or Twilio. To send messages or emails to the user. This can contain like invoices and general notifications.
Cool.
So okay, last not last step, but next step would be which would be our last requirement to get into detail would be PCI and GDPR compliance. As you can see, I haven't added a load balancer. That might be strange, but I think we should use an API gateway here. Most API gateways nowadays come with load balancing out of the box, and plus they can help us really secure the access to the API, especially REST APIs. So I'm inclined to go towards API gateway here. What are your thoughts on this?
Yeah. So what happens if a user is coming from like a sensitive geography like Europe? How would this API gateway help us?
Okay. So assuming we are running our service in multi-region, like there's service cluster for US, Europe, India, and so on. If a user is coming from, let's say, Europe, we can use like a geographical policy routing and something similar. Many services implement that, like AWS Route 53, and they can be implemented either at the gateway level with like headers, IP address, geolocation, and they can forward the traffic to the correct service. So this is an issue that we have tackled at my current company as well, because uh, we serve clinical trials for a huge number of companies in US and Europe. So Europe has like a GDPR laws, so we need like a separate set of services. So API gateway can be really helpful here, or we can redirect the traffic from the DNS itself.
Makes sense. Cool.
Perfect. And plus it can help with securing our API. API gateways usually come with like some sort of like basic firewalls, which is great for PCI compliance. And they have like logging metrics, everything built in, which we can use later. Like business team can use those analytics and see, hey, people are purchasing this, so this must be important. So that's kind of the goal with the API gateway here.
Cool. Sounds good. Um, if you didn't have anything else to talk about, I'd love to dive a little bit into how you'd shard or partition the database.
Perfect, perfect. For sharding, I would like to. Do you mind if we do like a very basic data model for the database?
Yeah, for the sake of time, since we're like running short on time, feel free to just come up with like a very basic data model and maybe like talk through like one or two ideas on how you shard.
Okay, so first would be ID and user ID method. So this is the transaction record that I am envisioning on storing. So this is the, again, enum, currency, created at. Um, okay, so I guess I'll forward the amount. This would be coming from the payment service provider. Currency would be ISO 42719, I think, and method would be like a credit card, debit card. And we also have status, like pending, success, fail. Okay. So this is kind of the basic data model we'll be working with. And for sharding, we can, okay, so sharding, either we can use like an existing scheme, like, hash based partitioning, or, range based partitioning, or we can just create our own like a composite model. So in my opinion, I think user ID would be great to shard as a sharding key for our database, because it would be like, so okay, so if the user is from US and Europe, they would be redirected to the like correct shard. And but this can cause issue with the rebalancing, because our database can skew if there are like more users in India. So the shard of the India would be like so much bigger than the US and other countries, and and join across shards is again very complex. So this will bring us to consistent hashing. But for sharding, to answer your question, I would go with the user ID as our primary objective to shard, or we can also use metadata such as user location to create a shard for a Europe shard, a US shard. Um,
Yeah, what's the idea behind sharding by user ID? Is the assumption here that the user IDs are sequential and we might want to, yeah, is that like, is there some kind of assumption here on why we might want to shard by user ID?
yeah, so for sharding with user ID, my assumption here is we are already authenticated with the internal, Amazon auth. And for sharding across with the user ID, it would be simpler, as I believe that user ID can fall in a certain geographical area. Or maybe we can, yeah, I think you're right. I think we should not use user ID, and maybe we should just use the, geolocation, um, like a geohash or something like that to have as our primary sharding key. I think, yeah, user ID might not fit.
Okay. Yeah, I mean, like maybe the IDs are like randomly, like distributed to
Yeah,
users, so
exactly.
it might be hard to
Yeah, yeah,
locate like the user. No, but
yeah,
I think,
exactly. You're right.
I think,
Geohash might be a good thing.
Mhm. I agree. Yeah, I think geohashing is a really good way here. We can quickly just find like a user in India, right, in that partition, and then just go in there. Cool. Last question that I wanted to touch on here is, can we just touch on the the cap theorem trade-off here one more time? So, would love to hear like which one you'd prioritize there about availability and consistency.
Okay. Um, since like we are still not running for this particular system, we are not running billions of users. I think I will stick with RDBMS and just go with simple ACID and shard the database, have consistent hashing in place eventually. But if we are running for billions of users, it's expected to have like a distributed database. Then we can look into things like distributed transactions, two-phase commit, distributed consensus. So that's kind of the trade-off. But I will stick with RDBMS for this particular system for the requirements.
Got it. So, would you prioritize consistency or would you prioritize availability?
Okay, I would prioritize consistency here.
Okay. And what's the thoughts behind that?
Um, I think for this system, 10 million users, the relational database, which gives us consistency, should work fairly decently, in my opinion. And we don't hit the scalability limits with relational database until like there's actual challenges. Um,
Got
so
it. Okay, cool. Thanks, Karan. I think this is a great mock interview. I really enjoyed how you walked me through your whole flow here, and you talked about how you take into considerations like GDPR and sharding, and I thought this was a great conversation. So thanks for your time on today's show. And before we wrap things up, I've taken a look at the GitHub book that you've written. It's very amazing, very in depth. Is there any sort of tips or advice that you can give the audience if they're preparing for a system design interview?
yeah, absolutely, Kevin. My only tip would be just focus on the requirements and kind of the data model, how data flows through the system. That's kind of the key of the system, and other things will just kind of fall into place, in my opinion.
Great. Awesome. Well, thanks so much again for your time, Karan. And for the audience watching at home, hope you enjoyed this payments system design mock interview. And good luck with your upcoming system design interview. Bye bye.